Welcome back, students. In the previous lecture, we have discussed about the refraction of light, and today we are going to discuss about the our new topic, two refractions through a rectangular glass slab, or the simply lateral shift or lateral displacement suffered by a beam of light when it is incident on a glass slab. Let's discuss about this one. Let us consider a glass slab, rectangular glass slab. Suppose this is our rectangular glass slab ABCD, and suppose a ray of light is incident at point P, and here at point P we have a normal N1, and the incident light makes an angle of I1 with the normal. As the upper medium is air and this medium is glass, when a ray of light goes from air to glass, it is going from rarer medium to denser medium, then it will bend towards the normal. It will bend towards the normal. Okay, so this angle is our, suppose, R1. According to Snell's law, apply Snell's law at air glass interface. Air glass इंटरफेस हम कहाँ पर बात कर रहे हैं? इस सरफेस के लिए, ए बी सरफेस के लिए बात कर रहे हैं. एयर, जब हमारी लाइट क्या है, एयर से ग्लास के अंदर जा रही है, तो स्नेल्स लॉ के अकॉर्डिंग क्या रहता है हमारे पास? साइन ऑफ द एंगल ऑफ इंसिडेंस बाय साइन ऑफ द एंगल ऑफ रिफ्रैक्शन इज इक्वल्स टू the refractive index, but here the sign of the angle of incidence is I1, so I will write it as sin I1, and the sign of the angle of refraction is sin R1 is equals to refractive index, and the refractive index here is written in the form of relative refractive index, so I will write it as 1n2, or we can say it is going from air to glass. It is our medium 1, or we can simply write it as from AG, refractive index of glass with respect to air, as light is going from air to glass. Okay, and it can be written as refractive index of glass upon refractive index of air. Okay, so our equation is sin I1 by sin R1 is equals to Ng by Na. So it is our equation number 1. And if we talk about the second surface, when light is incident on the glass air interface, then suppose that it is incident on a point P. Suppose this is our point Q, and here we have a normal N2, and suppose here the angle of incidence is R2, and as light is going from denser medium to rarer medium, it will go away from the normal. It will move away from the normal. Okay, so this is our angle of emergent. It is angle of emergent because the light is emerging out from the denser medium to rarer medium. Okay, so for glass air interface, स्नेल्स लॉ अगेन अप्लाई करेंगे हम लोग. तो हमारे पास क्या रहेगा? साइन of the angle of incidence here at point Q, the angle of incidence is R2 by sine of the angle of refraction. Here the light is refracted through angle E. Here angle of refraction is E, and it will be equals to, again, relative refractive index. Again, light is going from glass to air, so we can write it as G N A, or it can be written as N A by N G. Okay, and this equation can be written as sin R2 by sin E is equals to Na by Ng. Okay, when we रेसिप्रोक दिस इक्वेशन मींस हम क्या करते हैं, इसको क्रॉस मल्टीप्लाई कर देते हैं, तो हमारे पास ये इक्वेशन किस फॉर्म में कन्वर्ट हो जाएगी, एन जी रिफ्रैक्टिव इंडेक्स ऑफ ग्लास अपॉन रिफ्रैक्टिव इंडेक्स ऑफ एयर इज इक्वल्स टू साइन ऑफ द एंगल ऑफ इमर्जेंट अपॉन साइन ऑफ द एंगल ऑफ इंसिडेंस R2. ओके, R2 हमने क्या किया है, क्रॉस मल्टीप्लाई कर दिया, साइन ऑफ एंगल ऑफ इमर्जेंट ऊपर चला गया, रिफ्रैक्टिव इंडेक्स ऑफ ग्लास इधर से क्रॉस मल्टीप्लाई होगी ऊपर, और ये डिनोमिनेटर में चले गए. ठीक है, अब इफ वी कंपेयर द इक्वेशंस, अगर हम क्या करें, इन दोनों इक्वेशंस को कंपेयर करें, इक्वेशन 1 और 2 को, कंपेयरिंग इक्वेशन 1 एंड इक्वेशन 2, we can see that the Ng by Na, refractive index of glass with respect to refractive index of air, is equals to sine of the angle of emergent upon sine of the angle of incidence, and again it is equals to sine of the angle of I1 upon sine of the angle of R2. So from there, these two quantities are same, then these two quantities will also be same, so we can write it as sine I1 upon sine R1 is equals to sine of emergent upon sine of incidence. Okay, from there we can see that these two normals are parallel to each other, and this is a secant line, and we know that the angle R1 is equals to angle R2, alternate interior angles. Okay, from there we know that angle R1 is equals to angle R2. If angle R1 is equals to angle R2, then we can write sine of I1 upon sine of R1 is equals to sine of emergence equals to sine of, in place of R2 I am writing here again R1, and these terms cancel out each other, so we remain with the sine of the angle of I1 incidence is equals to sine of the angle of emergent. Okay, so this is our result, means that the angle I1 is equals to E, इंसिडेंस एंगल, जिस एंगल के ऊपर हमारी लाइट इंसिडेंट हुई है AB इंटरफेस के ऊपर, एयर ग्लास इंटरफेस के ऊपर, उसी एंगल के ऊपर हमारी लाइट क्या हो रही है, बाहर निकल रही है ग्लास एयर इंटरफेस से. इसका मतलब क्या हुआ कि जो इंसिडेंट लाइट है और इमर्जेंट लाइट है वो क्या रहेंगी, पैरेलल रहेंगी. ओके, अगर हम इसको इंसिडेंट लाइट को आगे की तरफ एक्सटेंड करते हैं तो हम देखेंगे कि ये दोनों लाइट रेज क्या हैं, पैरेलल जा रही हैं, और यहाँ से इन दोनों इंसिडेंट लाइट और इमर्जेंट लाइट के बीच का जो परपेंडिकुलर डिस्टेंस रहेगा, ये परपेंडिकुलर डिस्टेंस जो रहेगा इसको हम बोलेंगे लेटरल डिस्प्लेसमेंट और लेटरल शिफ्ट. ओके, तो ये हमारे पास क्या रहेगा, लेटरल डिस्प्लेसमेंट और लेटरल शिफ्ट. ओके, सो जब भी हम क्या करते हैं, किसी भी रेक्टेंगुलर ग्लास स्लैब के ऊपर कोई लाइट रे इंसिडेंट करवाते हैं, तो वहाँ पर हमेशा ही क्या रहेगा, एंगल ऑफ इंसिडेंस एंड एंगल ऑफ इमर्जेंट क्या रहते हैं, इक्वल रहते हैं. सो गाइस, ये हमारा लेटरल डिस्प्लेसमेंट और लेटरल शिफ्ट था. अब हम कुछ न्यूमेरिकल्स के बारे में पढ़ेंगे. ओके, let's talk about some numericals. First one is light travels from water. Light travels through water with a speed of 2.25 into 10 raised to power 8 meter per second. What is the refractive index of water? Okay, so as we know that the refractive index is equals to speed of light in medium 1 by speed of light in medium 2. Okay, and here you are taking the case of that light is traveling from rarer medium to denser medium, and I am taking here the rarer medium is vacuum, because it is given that the speed of light is 3 into 10 raised to power 8 meter per second. The speed of light in water is this one, and speed of light in vacuum, here the vacuum is medium 1 and water is medium 2, so the refractive index n is equals to c by v, and the value of c is 3 into 10 raised to power 8 meter per second by speed of light in medium 2 is 2.25 into 10 raised to power 8 meter per second. Again this quantity cancels out each other and we have 3 upon 2.25, it will again equals to 300 divided by 225, and when we cancel these terms we have 60, and it is again 4 5, and it will be equals to 4 by 3, and it is equals to 1.33. So the refractive index of water is 1.33. Okay, now let's move towards the second numerical. Light travels from rarer medium 1 to denser medium 2. Suppose this is our interface, and it is medium 1 and it is medium 2, and light travels from medium 1. Suppose this is medium 1, light travels from medium 1 to medium 2. Suppose this is our normal n, and it is traveling from rarer medium to denser medium, then it will bend towards the normal. Okay, the angle of incidence and the angle of refraction are respectively 45 degree and 30 degree. Here the angle of incidence is 45 degree and angle of refraction is 30 degree. Okay, calculate the refractive index of the medium 2 with respect to medium 1. So here we have to find the relative refractive index, and which can be represented by light is traveling from medium 1 to medium 2, so we have to find 1 and 2, 1 and 2, and it will be equals to sine of the angle of incidence upon sine of the angle of refraction, and here the angle of incidence is 45 degree, so sine 45 degree upon sine 30 degree, and we know that the value of sine 45 degree is 1 by square root 2 and sine 30 degree is 1 by 2. If we solve, we have 2 by root 2, and 2 can be written as root 2 square upon root 2. 1 root 2 cancels and we have square root 2. So the relative refractive index, or the refractive index of medium 2 with respect to medium 1 will be equals to square root 2, and the value of square root 2 is 1.414. Let's move towards the next numerical. If refractive index of second medium with respect to first medium is square root 2, then find refractive index of first medium with respect to second medium. From this question we will use the relation that refractive index of second medium with respect to first medium is equals to 1 by refractive index of first medium with respect to second medium. Here it is given that the refractive index of second medium with respect to first medium, and we have to find the refractive index of first medium with respect to second medium. So we have n1 2 is equals to 1 by n2 1. Okay, so let's put the values. The value of refractive index of second medium with respect to first is square root 2, so it will be equals to 1 by root 2, and it will be equals to, we have to multiply it by square root 2 and square root 2, multiply and divide by square root 2, then we have the value square root 2 divided by 2, and it is equals to 1.414 by 2. So the refractive index will be equals to 0.707. Okay, it is given refractive index of second medium with respect to first medium, and the refractive index of first medium with respect to second medium is 0.707. In the next question, how much time light takes to cross 2 millimeter thick glass? The thickness of glass, I am writing the thickness of glass as x. It is 2 millimeter. We have to convert it into meter, and when we convert millimeter into meter, it will be equals to 2 into 10 raised to power minus 3 meter. Okay. If the refractive index of glass is, refractive index of glass n is 3 by 2. Okay, and refractive index is given here. We have to first find out the speed of light in the glass, and from the refractive index we know that n is equals to c by v, or v is equals to c by n. Here v represents the speed of light in glass and c represents the speed of light in vacuum, and n is the refractive index of the glass. Let's put the values here. We have c is equals to speed of light in air is always 3 into 10 raised to power 8 meter per second upon refractive index of glass is 3 by 2. 3 divided by 2, 3 cancels each other, and it will be equals to, v will be equals to 2 into 10 raised to power 8 meter per second. So the speed of light in in glass is 2 into 10 raised to power 8 meter per second, and we have to find the time, and we know that the velocity is equals to displacement upon time, and from there we have to find the time only. So we will put we will cross multiply it, then time will be equals to x displacement upon velocity. Here displacement is equals to the thickness of the glass, so thickness of glass is 2 into 10 raised to power minus 3 upon velocity is 2 into 10 raised to power 8. 2 cancels each other, then we have this power goes upside, then power becomes negative. 3 into 10 raised to power 3 multiplied by 3 into 10 raised to power minus 8. In denominator power is positive, and if it goes to the numerator, then power becomes negative. Base is same, so power will be added, then the time will be equals to 10 raised to power minus 11 seconds. Light will take 10 raised to power minus 11 seconds to cross a thickness of 2 mm. Okay, so guys, these are the some numericals on the previous topics. Thank you.